Hello, in this video I will give you a very quick overview of the fundamentals of PDE Control and highlight a few examples of applications in industry and engineering. In general, in control theory and systems theory, we are interested in control of a system P with some dedicated control inputs U, some measured outputs Y, and possible external disturbance input signals. In most control problems in control engineering, the control system P is either a physical system or a mathematical model, which is described by either a linear or nonlinear ordinary differential equation, which describes the evolution of the state of the system. And this is true, for example, for electrical circuits, mechanical systems, and different types of robotic models. On the other hand, in PDE control, the control system P is instead described by a partial differential equation whose state depends on also other variables besides the variable t, time. For example, very typically a position variable is involved, but these other variables can have other interpretations as well. And in addition, the model of the system, the partial differential equation, involves differentiation of the state with respect to both the time variable and the other variables as well. Models described by partial differential equations involve, for example, models of temperature distributions, modeled and described by heat and diffusion equations, mechanical systems with flexible or vibrating components and structures, modeled by beam, plate, and wave equations, and especially fluid flows modeled by convection or transport equations. Our first example concerns the control of a robotic arm or a robotic system with flexible components. If we consider the control of the robot arm on the left, you can see that it consists of joints which can be used as the actuation, and then the links which may be flexible. And in order to describe the dynamics accurately, these flexible links should be described by beam equations, for example, Euler-Bernoulli beam equations or Timoshenko beam equations. And situations where the flexibility of the robotic arms cannot be neglected arise, for example, in space engineering, where the combined large scale of the structures and lightweight materials make the robotic manipulators increasingly flexible. On the other hand, the same situation appears in nanoengineering, where the extreme small size and thinness of the materials make the robotic manipulators flexible as well. On the other hand, control of PDEs can also be used in control design for traffic flows. And whereas one single vehicle or a small group of vehicles can be described by a system of ordinary differential equations, the dynamics of an increasingly large formations and groups of vehicles can be approximated with good accuracy with partial differential equation models, which leads to so-called limit equations or mean field equations. And this kind of approximation scheme allows PDE control to be used, for example, to reduce traffic jams and smooth out traffic on highways. And in such situations, for example, variable speed limits can be used as control actuators. Besides these couple of particular examples, PDE control also appears in other processes in industry and engineering. For example, control of temperature profiles related to heat exchange processes or industrial manufacturing processes, and these are described by convection diffusion equations. On the other hand, control of flows is important, for example, in industrial mixing processes, and analysis and control of fluid flows in pipe networks. And PDE control has, for example, been applied on the scale of European natural gas networks. And vibration control and rejection of disturbances and harmful vibrations is very important in the control design, for example, for drilling equipment, and on the other hand in passive control design and construction engineering for large-scale buildings and other built structures. And this concludes my very quick overview of the fundamentals of PDE control and some of its engineering applications. Thank you.